Hello friends, so today in this video we're going to discuss another problem from Leetcode, problem named deepest leaf sum. So as you can see, it's a medium level problem. It actually states that you are given a root of a binary tree in the problem statement and you have to return out the sum of the values at its deepest leaves. So as you can see in this problem, the deepest leaves are 7 and 8 because it is like in the end the deepest. So now as you can see, the summation of 7 plus 8 is 50 and that's the answer. Now you can also draw this like this test case and the answer is 19 here. But the simplest way to solve this problem out is to do like a level order traversal, because in level order traversal you move in a level wise fashion in any sort of tree. So the first move down to this level, then the second and third, and when you go to the last level, which means that when in every level you just find out its sum. So it's like finding out the sum of every level. It's a very standard problem and you can find out a couple of videos out there, but in this problem you just have to find out or return out the sum of the last level. And that's the whole problem. Now if you do not know binary search or actually binary like breadth first traversal, or you want like all a level or traversal, if you do not know, you can go and check out some another video on that, or there are plenty of full videos on breadth first search, like not breadth first search, like breadth first traversal in this concept, or like on YouTube. You can check those video out. Else I will also draw the example for this so you can also like understand it while seeing this video out. So this is the code part, but first we're gonna see. So as you can see, we solve the breadth first traversal, or like the level or traversal, using using a queue. And then how we're gonna do this, I will tell you. So let's assume that this is the tree. So what you'll do, you will make a queue and you will push down the first node. So let's mark them out, these nodes 4, 5, 6. You will push down the first node value and a null value in the queue. Okay, so now null value defines that this is the end of this level. So you will make a sum variable which will store out the sum till you hit a null variable or like a null pointer in this queue. So you will first see 1, you will add 1 in this value, and then you will encounter and you will pop out from this. Now if you pop out some value, you will check that whether it is a left child. If it is a left child, insert this in the queue. If it is a right child, insert into the queue. So that you have inserted the next level, and then you pop out this element. Now when you encounter null, you have to see that whether this null is the last null, whether the queue become empty after after removing out this null. No, there are some more levels, like some more elements, which means that this level is not completely, like this tree is not completed, like there are some more elements. The next level is out there, so this is not the last level, so you have to go ahead. But when you encountered a null, it actually also states that the next level elements are already inserted. So it means that, as you can see, the next elements are also inserted. So you have to mark the next null, which marks out because you have completed the first level and all the next level elements are inserted. So it means that now you have to insert another null to mark out the end of the next level. Next you will pop out this element, then you will go to 2. Okay, 2. Then you will check that whether the left side element of 2 exists. Yes, but put that into the queue and pop out this current element, and then because before popping out, add it to the sum. The sum become now 2, because the sum will become 0 after you have encountered null, because the level has completed. Now you will go to 2, you will put that here and you will insert the next element. Then you will go to 4, you will check that okay, 4 is there, we are on the same level because null is not encountered. You will add 4 to it, it will become 6, and you will check that whether it has more elements. It has 5 and 6, so you will insert 5 and you will insert 6. And then what you'll do, you will pop out this element also. After popping out this element, what you'll see, you will see that there is another null, which means that now this level is also completed out. After this level is also completed out, whether there is more elements in the queue, or yes, there are more elements, which means that there is some more level you have to go. So you have to another insert one more null. It is like, if you know that like the level of the traversal, it will be easy to understand. Then you are gonna insert it out another null, and you will see that okay, now on 3 whether there are some more elements. No, do not insert any element, pop out. So now, because this is not like you have inserted null, you will make this again 0, because this is not the last level. Now you have inserted 3, so add 3. Now 5, add 5. 6, add 6, because there is no children, nothing is added after null, and you will take out everything. Now you will again come to null, and you will pop out null, and you will see that now there is no element ahead of null, because everything is popped out. So when the queue becomes empty, it means that now we are on the final level, and when we are on final level, this is the total sum, and that's what we have to do. And that's the whole logic for this problem. I'll take on to the code part now to make it more clear. This is like a simple trivial condition. This is not actually required, but this is the queue. You have to first push down the root node and the null to start out the queue. Then this is the total summation which I've told you, and this is the last sum value. Okay, and we will do this while loop till the queue do not become empty. What we'll do, we'll pop out the top element and pop it out from the queue. Then if it is null, or first talk about that whether the top element which you have popped out, if it is not null. If it is not null, we are on a current level. So what we'll do, you will add out this current value on the sum value, and you will check that whether the left child exists. If it exists, insert it in the queue. If the right side exists, push that in the queue. If it is null, which means that if the current element is null, which I've told you, if the current element is null, what I actually have to do here is, I will check that whether the queue becomes empty. In the end, only the queue becomes empty. If the queue becomes empty, the sum which we have till now is the last sum. So we will put that into the last sum variable, storing out, and just break out of this while loop so that we can print out. Else, if it is not the last sum, which I've told you, if there are some more elements here, then I will again insert another null element afterwards, so that to mark out the next level break. So because after every level there is a null which marks out the break of that level, and we have to again initialize my sum equal to 0, because we have completed the current sum value, and the current sum value is not the last depth value which we want. So we have to again initialize the current sum, or the level sum, to 0, so that we can again start storing that sum value here. I hope you understand the logic and the code part for this problem. If you still have not, so you can mention down. The code will be in the description, so you can check the code out also. I'll see you in the next one. Till then, keep coding, and bye.